Hello guys, I'm going to show you this example from exercise 9a in the textbook. The question asks, 16 people were surveyed to find out how many phone texts they sent that day. The raw data is as follows. So you can see one person sent 10 texts, one person sent 7, one person sent 2, one sent 5, and so on. So we need to organize the data into a frequency table using class intervals of 10, and also we need to include a percentage frequency column in our table. Then construct a histogram for the data, showing both the frequency and percentage frequency on the one graph. Okay, then we got to construct a stem and leaf plot for the data. And finally, we got to use that stem and leaf plot to find the median. Great. Okay, so first let's set up this frequency table. Let's do A. Well, we've got to set up our class intervals. This is going to be the frequency. And this question also wants the percentage. Oops. What's the percentage frequency? So a table's going to have 3 rows like this. And we'll start with the class intervals. So the question says it wants class intervals of 10. So what does that mean? It means I can't, put each of these individual data points down. I need to group these data, I need to group this data into intervals. And the intervals I'm going to pick are intervals of 10. So the first interval I'd probably select would be 0 to 10. And I might say greater than or equal to 0, but less than 10. That might be my first interval. Well, my second interval is got to be 10x 20. This is my second interval of 10. And so on. Let's see how high I'm going to have to go up to. I see the largest number I can spot right now appears to be 32. So that means I'm going to have to go all the way up to an interval of 30 to 40. So I need one more. 30x to 40. Okay, so I'm just going to run through and I'm going to quickly tick or cross off the answers that fall into the first class. So 10, well, 10 is actually going to fall into this class, the second class, because we see that we are greater than or equal to 10. So 10s will fall into this second class. For the first class, we're going to have 7, 2, 5, 7, 9, and 5. So a total of 1, 2, 3, 4, 5, 6. Frequency, there's 6 data points that are between 0 and 10. Okay, how about between 10 and 20? Well, there's 1, 2, 3, 4, 5, 6. There's another 6. How about between 20 and 30? There's 1, 2, 3. And between 30 and 40, there is just the 1. Okay, so we've got the frequency for all of our data here. If we wanted to find the percentage frequency, well, we can see that there's 16 people surveyed. So the percentage of people in this first class, 0 to 10, is going to be 6 out of the total 16 times 100. Right, so let me just 6 out of 16 times 100. First is going to be 37.5. And the frequency is the same in the second class, so the percentage frequency is going to be the same. 37.5% of the data falls inside this first class. Another 37.5% of the data falls inside this second class. Now, half of 37.5 of the data is going to fall in the third class. Or we could just say 3 over 16 times 100. 18.75. See, half of 37.5, as you can see, will fall in this third class. And then 1 over 16 times 100. 6.25 It's going to fall in this last column. Okay, so that is our frequency table done. And we've got our percentage frequency as well. Now let's do B, construct a histogram. So we needed both the frequency and percentage frequency on the one graph. Well, since frequency and percentage frequency were more or less measuring the same thing, we could have them sort of parallel. And so here's what I mean. We'll have frequency over on the left hand side here, and then we'll just say percentage frequency. We'll have it over on the right hand side. So frequency as a percentage, and then frequency as a number. And what we'll do for our scale, we'll set up not our intervals, we'll set up just a regular old number scale. 0, maybe I'll go to 10, then I'll go to 20 over here, 30 over here, and then we'll finish off at 40, and I might just make this a bit more kind of, I don't know, neat, I guess. Well, I cooked it. I'll take that back. There we go. Okay, so I'll set up my table a bit like this, and then on the left hand side we'll go up frequency 1, 2, or we'll go 2, 4, actually no, 1, 2, 3, 4, 5, 6, that'll work. And so 6, that's going to correspond with a frequency of 37.5%. And we know 3, that's going to correspond with a frequency of 18.75%. So it's pretty arbitrary what I'm picking my scale to be. And that's fine, because we're just looking to fit data to this in an accurate way. Okay, so now I'm going to draw my histogram. So for my first interval from 0 to 10, we have a frequency of 6, or a percentage frequency of 37.5. For my next class, 10 to 20, we have again a frequency of 6 and a percentage frequency of 37.5. Next, for 20 to 30, we have a frequency of 3, and for 30 to 40, we have a frequency of 1. So here's our histogram. Some key points about histograms. Check out how our intervals are connected, like our bars, they're touching in this histogram. On a bar graph, that's not the case. A bar graph might look something like this, where we've got separated bars, right? And so the reason why this is really important to mention is because, well, histograms, we can actually use them to describe continuous data now, because there's no break. There's no break. As we travel through this number scale, there's no break. There could be data anywhere along this number line, couldn't there? Along this x-axis. However, if we look at this column graph, there's breaks. So let me draw this just vertically. Here's just like a random column graph or a bar graph. You see there's breaks. So we could have potentially a number here, like this could be 3, and this could be 4, and this could be 5. You see there's breaks in this scale. So we don't have continuous data values that are possible. We could have 3, or we could have 4. We couldn't have 3.5 or 3.725 or whatever, right? There's only discrete values we can take on a column graph. A histogram, there are no breaks in these intervals, so it allows us to represent continuous numerical data. So that is the histogram done. Now let's construct a stem and leaf plot for the data. We'll do that over here. So stem and leaf, we'll start with the stem. Stem is going to be 0, 1, 2, 3. And we could go up to 4, although we don't need to. Let's not go up to 4 because it's just going to confuse the matter, I feel. but the numbers with a stem of 0. So this is like our tens, and the leaf is our ones. And so if I'm looking at numbers with tens of 0, that's going to be all my data in my first class, all these 6 data points. So it's going to be 7 2, 5 7 9 and 5. 1 2 3 4 5 6. It's going to be these 6 data points that I need to fill in this first line. Catch is, it needs to be in numerical order. So I'm going to have to say 2 5 5 7 7 9. Next, for the tens, well, we're going to have 10. That's going to be first, 11, 12. So we'll just start writing these down so I don't forget. 10, 11, 12, and it's looking like 14, 14, 18. Next, numbers beginning with 20, 22, 29, and 24. So in numerical order, this will be 22, 24, and 29. And there's only one value with a stem of 3. It's 31. Oh, excuse me, 32, sorry. So here's our stem and leaf, and we might use this to find the median, okay, D. We need to use the stem and leaf to find the median. Well, that's just going to be a matter of working through this and finding the middle value. I do this every time. Oh, so we'll see that the median value is actually between 12 and 14. So the median is between 12 and 14 here, as you can see. What does that mean? Well, it just means that the median is going to be equal to the average of 12 and 14. That is 26 over 2 is equal to 13. That makes sense, right? 13 is halfway between 12 and 14. So this median line, that's halfway between 12 and 14, must be on 13. Cool. And that is the final question done. Alright, I'll just sort of zoom out so you can see all the work in one shot. And yeah, that's it.